All right, guys, let's keep going. We're in topic 22, problem number 21. Topic 22, problem number 21. Let's see how that's going to play out. And here it is. A man shines a flashlight from a boat into the water, illuminating a rock as in figure 22.21. What is the angle of incidence that takes place here? Okay, so this is pretty neat stuff. It should go pretty straightforward, but it's still a good question. It's still a very good question. So let's look at it. The guy's basically, they're showing a guy basically on a boat. And we're going to use Snell's law to get us through this. There's a lot of stuff you can do. Snell's law is basically saying N1 sine theta 1 equals N2 sine theta 2. So he's shining, and so there's a lot going on here. The light's reaching the rock. The rock is somewhere here. From here to here is 2.5 meters. The height from here to here is 3 meters. Okay. They're saying the light hits right here. It hits right here, and it just comes right down to there. So there's an angle here of theta sub 2. The guy's up here somewhere in a boat. There's somebody there, and there's a flashlight, I guess. This person holding a flashlight. I guess the flashlight is attached to his body, apparently. So there it is. It doesn't, there's the flashlight. And so, and he flashes it. And it hits here at theta sub 1. Simple as that. This is the angle. It's always, Snell's law, you guys, is always understood as the perpendicular, the angle with the perpendicular. This is the angle of incidence. This is the angle of refraction. And this holds, and this is the index of, the index of refraction, N1 and N2. And we know that N is C over V, right? But right now, we know a few things here. That's about it, guys. What is the angle of incidence for this to be taking place like this? You know a lot more than you think you know. Let's take a look at it. I'll tell you what I'm going to do. We know this is the case. We're talking about air and we're talking about water. And that's okay. So what we can say is this pertains to air, this pertains to water. Let's do a couple things. First of all, there's a lot of mathematics here. This is a side which is 2.5 meters long. This is another side which is 3 meters long. The rise of this much over this run, the opposite over the adjacent will give you the tangent of theta 2. The tangent of theta 2 is 2.5 meters divided by 3 meters. So 2.5 meters divided by 3 meters. Theta sub 2 is equal to the inverse tangent basically, again, it's rise over the run. Well, this doesn't look like a rise over the run. This looks like a run and a rise. Well, here's the opposite, here's the adjacent. Here's the opposite, here's the adjacent. Opposite divided by adjacent is the tangent of theta 2. Theta 2 is the inverse tangent of that. When you do it, you end up finding, well, you didn't find the angle of incidence, you found theta sub 2, which is 39.806. 39.806. All right. Degrees. That's theta sub 2. What's the other one? They didn't ask you for this one. We found this one. I want to find theta sub 1. Look at all that. Tell you what I'm going to do. Let me find theta sub 1 by finding sine theta sub 1 first. Is it true right here, guys? Can I take and divide on each side of the equation? Can I divide by n1? Sure. Can you take theta 1? What's the inverse sine of the sine of what's the inverse sine of the sine of theta sub 1? It's theta sub 1. The inverse sine of this gives you theta sub 1, and the inverse sine of this yeah, that'll get you there. Let's see what you got. You got this. You got the inverse sine, and here goes. This is medium 2, which is N2. This is medium 1, which is the air. The air is 1.0002926. I can't remember, I didn't think they pull that on us, but there it is. That's for the air. That's for the air. For the water, so for the water, what do we got? The water, I think, is just 1.33. Pretty straightforward. We can look that up. I don't know that we needed to go that far, but here's for the air. Here's the index of refraction for the air. Here's the index of refraction for the water. I think there's one more 3 on there, guys. Forgive me. Right there. I don't know. I think when I solved it, I didn't put it like that. I just put a 1. I think this thing rounds up close enough, given everything that's going on, it rounds up to a 1, or it rounds down to a 1. Not a big deal. Well, let's not lose a whole lot of sleep on that one. Let's just get it right. N2 is 1.333. N1 is 1.0002926, I think. I didn't use that. I think I just used 1.0. So just kind of be mindful of that. You may not have to do that. Sine this guy, sine theta sub 2. We just said sine theta sub 2 was 39.8. Sine theta sub 2 is sine of 39.806 degrees. Grind that out. We got it in the notes. Like I said, I used 1. So you might want to just take the 1 out of there. I have it here. You can take it out. You should still get the same answer, very, very much in the ballpark of where you want to be. I don't think it's going to be an issue. 58.58. .58 degrees, and that's 21, guys. Again, maybe we all be well tomorrow. I'm gonna try to do this tomorrow and get you guys through everything I wanted to talk about, and then also do it for another course that I have as well, and just try to make sure that we're all safe, right? Stay safe, you guys. And that takes us through topic 20, 21, 22, some stuff I wanted to say from topics 20, 21, and 22. Tomorrow I'll try to do 23, 24, 25, and that'll take us pretty much through the course. Okay, you're going to have to be reading a lot of this on your own, you guys. I mean, you know that. Read it on your own. You don't need to lose a tremendous amount of sleep on it, but please be reading this on your own. Look at what's there. Look at my problems. The more motivated you are to do this, I think the better off you are. This is obviously less than ideal. It's not what any of us plan to see happen, but you have a tremendous amount of notes in front of you that you can look into if you have the time to do it and if you want to do it. So look at this as much as you can on your own. Look at the book as much as you can on your own, and then look at the problems that I tried to do for you. And I think you're in good shape to finish this class. I think it's going to be that easy for you. I will see you soon. Take care. Bye now.